Hello Year 7 and welcome to lesson 4 of sales transport, and today we're looking at the osmosis practical results. So yesterday we set it all up, we wrote a method, and today we're going to look at what actually would happen and understand why. So before we get into that, you need a pen, a paper, and if you've got a resource to print this off, that's even better. So like normal, let's start with some retrieval. So first slide is on sales. Pause the video, off you go. So, how do you get on, guys? Again, if you need to pause the video, check your answers, revise, please do so now. Questions on slide number 2 are all about forces. So again, pause the video, off you go. And how to get on, guys? So again, if you need to pause the video to check, do so now. And the final slides are back to this topic, so osmosis and the practical and the method. So now, pause the video, what can you remember? So how to get on, guys? Pause the video. Again, I've written a method there, shorthand. It's a memory method for me. If you want to copy that, you can, but that is how I remember it. So today, we'll get on to practical in a minute, but first of all, let's go through the couple of stock questions from yesterday's lesson. So here they are. So question 1, 2, and 3 for you. Again, check your answers. Again, all about the variables here. It's all about the method and the practical side of it. You've then got the next questions are all about control variables and what we expect. Now, you might not have got this, but this is what we expect to happen. Is the idea that potatoes in the pure water will get heavier and the potatoes in high sugar solutions will get lighter. So we'll explain that during this lesson. So what I want you to do, guys, is now, while we're getting ready, is grab your sheet in front of you, which looks like this. If you haven't got this sheet, that is not a problem. Just work for me, okay? So, first thing to do is talk about, right, we need to look at the results. So here are the sets of results we've got. Now we can see that at low concentrations of sugar, so pure water, potato got heavier, and even at quite low concentrations, it got heavier as well. But as we increase the concentration of sugar, actually it's lighter and lighter and lighter. It loses mass here. So we've got negative numbers and positive. Now we've got a column here called percentage change in mass. Now it might be new to you, but in a second I'll explain how we work that out. So what we're going to do first of all is how do we do that? Now to calculate percentage change in mass, you need to know an equation. So it is this. To calculate the percentage change in mass, okay, we need to do the following. We do the initial, sorry, not the initial, we do the change in mass, and you divide it by the starting mass, and then you times that by 100. Now, the reason we do that, Year 7, is so actually we can get to the point where, no matter what the starting weight of a potato is, you can compare the result reliably. So let's get stuck into this now, okay? And we're going to do some maths again. I've got my phone here to help show what I'm doing. So we're going to start with 0. Now, if we look, its change in mass is 0.25. So change in mass is 0.25. Now, we're going to divide that by the starting mass, which is before, so that is 1.67. That gives you an answer of 0.149. Now we're going to times that by 100, and that gives us a percentage. I'm going to round that to 15%. So it's got heavier by 15%. Let's do the next one. So the next one, okay, we have got there a change in mass of 0.1. I'm going to divide that by the starting mass, which is 1.67, and I'll times that by 100. And again, it's got heavier, and this one's got heavier by roughly 6%. The next one then, guys, move the paper down so you can see it. It's actually got lighter by 0.17. I'm going to divide that by the starting, which is 1.64, and times that by 100. Now, because it got lighter, it is actually minus 10%. The next one, guys, the last two coming up, we've got a change in mass of 0.3. It started at 1.67, times up by 100. Again, it's got lighter, it's minus 18%. I am rounding this to the nearest whole number. And final one is the highest concentration. So we've got 0.52 divided by 1.65 and times that by 100. So I've got a big loss there of minus 32%. Okay, so we can see there that these ones got heavier and these ones got lighter. And then when you do the practical, you will see that these will be bigger, these will be smaller. But what I want us to be able to do now is plot a graph together. Now, if you want to go ahead and do it, you're more than welcome to, but I'm going to talk you through it, okay, here. So what we're going to do is I'm going to plot this with you, and you're going to, if you want to copy me, you're welcome to. And the first thing you do is get your ruler and draw a line all the way down that left-hand side of the squares. And then about halfway down, so I'm going to do it on 10 centimeters, okay? You want to make a sideways T. So your graph will look like this, because what we're going to do is we're going to show both positive and negative in the same graph. Now, the first thing I can do is do the x-axis. So I know I've got 0 here, and in every 5 boxes, I'm going to put a new concentration. So 1, 2, 3, 4, 5, 0.5, 1, 2, 3, 4, 5, 0.75, 1, 2, 3, 4, 5, 1. And that is the sugar concentration. Now notice, okay, you've got equal gaps between each of the numbers, and that is because they go up in equal amounts. So let's do the y-axis. On the y-axis, you are going to put, okay, I'm going to write here sideways, the percentage change in mass. Now, we can go up the side here. I'm going to go up every 2 boxes is 5. So 5, 10, 15. So 5, 10, 15, 20, 25, 30, 35. I'm not going any higher because I don't need to, but that's what you can do. But also, we can go down below 0. So again, we're going to keep the same scale. Every 2 boxes is worth 5. So this time it's minus 5, minus 10, minus 15, minus 20, minus 25, minus 30, minus 35, and that will do us as well because that's all we need. Now this is the hard bit. We need to plot a data. Now if we do it together. So first of all, here's my data. 0 is plus 15. So here is 0 and there is plus 15. So I'm going to do a cross there. My second one, 0.25 plus 6. So 0.25 plus 6. 0.5 minus 10. 0.5 minus 10 is here. So you'll notice the crosses are now below the x-axis. 0.75 minus 18. So 0.75 minus 18. And then finally, 1 is minus 32. So 1 minus 32. It's just there, isn't it? Now you should see that these results give us a lovely line of best fit, which will be a ruler, and that'll be a straight line of best fit. Now notice it's using a ruler, it's not dot to dot, and you just draw it straight through like that. And this is what your graph will look like. So the science behind this then. The potato's got heavier here, and it's got lighter here. The reason it's got heavier here is because water has moved into the potato. So I might write it, I'm going to write it here actually. Water is moving into the potato. Whereas down here, it's getting lighter. And that is because water is moving out of the potato. And it's because there's more water in the potato than outside, the concentration, so it's trying to balance up. And likewise, this one, there's more water outside than inside, so it moves to balance it out. And that is what you need to know from that graph. So to finish me today, I'm going to talk about a couple of questions to finish on about the practical. So I'm going to move this graph out of view now, and they look like this. So you've got 3 questions, okay, that I'm going to talk you through. So what is the concentration of solution inside a plant cell? This is really important. If we go back to our graph, there's a point in this graph which tells us the answer, and it's right here. Now at this point, the potato has not changed mass. It's stayed the same, and that tells us the concentrations are equal. So that means if we look at our graph, minus 0.25, minus 3, start again. 0.25, 0.3, 0.35. So the concentration inside the plants is 0.35, and that is because there is no change in mass. Okay. If we were suggesting improvement investigation, it's quite things you could say, but what I would say is we could use more solutions, or you could do it, repeat the experiment. Okay. Those would be the 2 I'd go for. And then finally, the errors in this practical. Now there's 3 main errors I could think of. You could weigh a wet potato. If you don't dry it off, you'll be weighing the water as well. You could also have said having the same size potato in each one. So again, that could be an error in the practical. And finally, the last one is having the correct volume of solution. And again, just another error that could cause an anomaly. Luckily, the results I gave you were perfect, but you can get anomalies as well. So that is the practical done, and that is what you would expect to happen in the practical. You've got a couple of slot questions to think about now, okay, and here they are. This is number 1, talks about eggs. Again, have a think about applying your knowledge from safe essence to this question here. And question 2, it's just 3 questions there, A, B, and C, about a very similar practical that they've done, and again, just thinking about what you've learned. So what we'll do is, again, we'll go through the answers next lesson, and next lesson is on active transport. Until then, make sure you use a material practice for me, okay? Complete the slot to the best of your ability, and then share the video. Otherwise, have a fabulous day, Year 7, and I'll see you soon.